So now let's continue with the toppling second lecture. So please write the question and pause it and solve. Okay. Question is, a block of height h is projected along a rough surface of coefficient of friction mu. Find the point of application of normal force. Find the point of application of normal force on the block if mu k is given 0.5. Mu k is given 0.5. Pause करो, मॉस करो, सॉल्व करो. Okay. Let's say we have. I'm solving now. You pause it. This is rough surface. Projected means it has been given a velocity. Center of mass is given a velocity. Okay, v naught. So rough surface है तो between this and this the Fk act होगा kinetic friction. तो draw the FBD वही करना है अपने को. तो its mg will be here. And again you can see about center of mass, torque due to Fk is in this direction. So n has to act, because अगर n इस साइड से act हो गया, अगर n यहाँ से act हो गया तो n का भी torque ऐसे ही आएगा. तो n has to act from somewhere here. This is n. Or you take any, means x you take anything, value will come automatically. You don't have to worry कि कहाँ पे आएगा. अगर तुमने जो assume किया, अगर x वही पॉजिटिव आता है मीन्स करेक्ट है तुम्हारा assumption. अगर तुमने assume किया और x आता है नेगेटिव मीन्स उसके जस्ट अपोजिट साइड हो जाएगा. So here, so this object is what? It is in translationally it is moving, but rotationally it is in equilibrium. So here in this case there is a rotational equilibrium. देखो लास्ट टाइम हमने किया था object was translationally it was in equilibrium. तो ये क्वेश्चन किया था हम लोगों ने, याद है कि यहाँ पे मैंने F, यहाँ पे F. So this object was translationally it was in equilibrium, but rotationally it was not. It was moving, couple of force. In this case, this object is translationally it is moving. So net force is not zero translationally. So along horizontal direction it is not in equilibrium, but in vertical direction this is in equilibrium. So we can write here n equal to mg. वो तो होगा ही in a vertical direction, but it is in vertically this is in equilibrium. Case 2 will be now torque. This is not rotating, this is in pure rotational equilibrium. So torque about center of mass I am writing. So torque about center of mass has to be 0. क्या हो जाएगा? तो ड्यू टू एफ के टॉर्क ऐसे होगा, ड्यू टू एन ऐसे होगा. तो एफ के इंटू this whole height is h given. So this is h by 2. This must be equal to torque due to n. So n into, let's say this distance is x. So n into x. Fk is how much? So again if you remember, Fk is mu k times of mg. Put the value here. So mu k mg h by 2, this is equal to n is mg, x, mg cancel. So from here x is mu k h by 2 and mu k is given 0.5. So x is h by 4. So normal reaction has to act h by 4 distance from the center towards right hand side. Okay. Okay. Next question, which I'll give you today. I won't be solving that. You have to solve again. I will solve in the maybe in the next class. Okay. Question is, and this is एडवांस वाले तो सॉल्व करेंगे ही विदाउट फेल. बाकी लोग ट्राई करो, बिकॉज इससे अपने को 2-3 कॉन्सेप्ट सीखने को मिलेगा. इसीलिए a car of mass small m, a car of mass small m traveling at a speed v, traveling at a speed v, capital V, moves on a horizontal track. Center of mass of the car, center of mass of the car describes a circle of radius small r, describes a circle of radius small r. If 2a, 2 small a, if 2a is the separation of inner and outer wheel of the car, if 2a is the separation of inner and outer wheels of the car, and small h is the height of the center of mass above the ground, find the limiting speed, find the limiting speed beyond which car will overturn, find the limiting speed beyond which car will overturn. ओके तो पहले पॉज करके सॉल्व करो, मैं आंसर मैं बताता हूँ. ठीक है, तो आंसर इज अगेन यहाँ पे कार का डायमेंशन दिया हुआ है, तो यू कैन नॉट अज्यूम कार एज अ पॉइंट मास. जो हमने सर्कुलर मोशन में किया था, when car was taking turn on a horizontal road, we had not taken, or on a inclined road, that is बेंडिंग ऑफ रोड जो था, ठीक है ना, तो इफ वहां पे उन्होंने डायमेंशन लिया नहीं था. ओके, हियर दे हैव गिवन अ डायमेंशन, मीन्स यू हैव टू केयरफुल अबाउट mg, नॉर्मल रिएक्शन एंड वॉट एवर इट इज रिक्वायर्ड. सो आंसर इज बेसिकली v स्क्वायर इज GRA/h. This is the answer. So this you have to find. R is the radius of the circle which is taken by center of mass of the car. 2a is the distance, a is the distance, 2a is the distance between the inner and outer wheels, h is the height of the center of mass. Okay, so this question you have to solve, and I'll explain this in the next video lecture or next day. Okay, here again difference क्या है, the same question we have done in circular motion. There we have taken car as a point object. Okay, because their dimension is not given. Here dimension is given. So dimension, the moment dimension is given of any rigid body, you have to consider translation also, rotation also. There on a horizontal circular path also we have not taken dimension of a car, और when we have banked the road, banking of road में भी ऐसा कुछ लिया नहीं था. तो try करना ये question and try to solve it. Next is now energy conservation for rigid body. So give the heading energy conservation for rigid body. I think this I'll cover in the next video, because short videos are very easy to upload on a YouTube. It takes less time and you also watch properly. Okay, so let's go for, so I'm just writing date and lecture number of that date. Okay, like today we have done lecture number 1, this is lecture number 2. So in the next lecture we'll be doing the energy conservation for rigid body. Okay, so keep watching Milestone Academy channel. Thank you.